if k is an integer and 35 squared negative 1 divided by k is an integer, then k could be each of the following except. So most times students, they forget this except here. So there's an except here, except all of these options. So what they're asking is which of the following options does not satisfy this condition we are given here. So again, you recall we said whenever you hear the word integer, what should come to your mind is whole numbers. Whole numbers. When you say whole numbers, both positive and negative whole numbers, anything like -5, 4, 0, 3, all of them like that, they are all integers. So we are told that k is an integer, and then also the expression we have here, that is 35 squared minus 1 divided by k, is also a whole number. So if these two statements are true, then we are now told to check which of the following values of k would ensure that these two statements must be true. Alright, again, like I said, the best way to handle problems like this is whenever you have anything or any expression that has been disguised in an equation of this format, you should try and simplify it before you begin to solve or answer any question. So this is just ordinary k, but here we have 35 squared minus 1 divided by k. So let me see if I can break this down. This 35 squared minus 1 divided by k. Now to break this down, you need to recall the difference of two squares. That is, if you have a squared minus b squared, this is the same thing as a negative b times a plus b. This is what we know. And then what we have here is 35 squared minus 1. 1 is the same thing as 1 squared. So this is just going to be the difference, 35 minus 1 times 35 plus 1. That is what we have. So 35 minus 1 is the same thing as 34 times 35 plus 1 is the same thing as 36. So to cut a whole long story short, so what we have here is 35 squared negative 1 all divided by k. This is just going to be the same thing as, so what we obtained here was 35 squared minus 1. We obtained it as 34 times 36 divided by k. So this is a simple format. Now again, to solve this problem, I'm going to try and break each of these down further. I want to find the prime factors of 34 and 36. Now how do I find the prime factors of 34 and 36? So you recall, so you have 34, the lowest number that can go in 34 is 2, 2 in 34 is 17, and then 17 goes here, you have 1. So this is 1, and then 36, for 36 you have 2 in 36, that's going to give you 18, and then 2 here goes here 9, 3 goes here 3, and then 3 goes here 1. So in other words, I could rewrite 35 squared minus 1 divided by k as, so my 34 here is now 2 times 17, then times my 36 here is now 2 times 2 times 3 times 3. Now all divided by k. So this is what I have. So what I'm going to be doing now is I'm going to be substituting each of the values of k. So when k is 8, I'm going to see if 35 squared minus 1 all over k is still going to be an integer, because we said we're told that k must be an integer. So all these values of k here, they are all whole numbers, so this is satisfied. So all I need to check is 35 squared minus 1 all over k, is it still an integer? So that's what I want to confirm. So for the first one, that's for a, when k equals 8. So when k equals 8, so that's for a. So when k is 8, when I substitute k equals 8 here, so what I have here, that is 35 squared minus 1 all over k, what is it going to give me? So you have 2 times 17 times 2 times 2 times 3 times 3 all over 8. So you can see 2 here, this is 4, 2 here, this is 2, and then 2 here, this is 1. So there is no remainder. So since there is no remainder, then that implies that this 35 squared minus 1 all over k must be an integer. So this passed the test. So we'll go to the next one. when k is 9. So that's for B, when k equals 9. So when k is 9, so I'm going to make the substitution here. So when k is 9, what you're going to have is 35 squared minus 1 all over k, which is this whole thing here, is going to be 2 times 17 times 2 times 2 times 3 times 3 divided by, now our k is 9. So you have 3, they cross this out, we have 1. So this also passed the test. Why? Because there is no remainder. So this passed the test. So let's go to 12. Now when you consider 12, so let me just write that here. So you have C. So for 12, so we're going to have is that when k equals 12, so what we obtain is 2 times 17 times 2 times 2 times 3 times 3 divided by 12. So again, here you have 2 here goes here 6, 2 here goes here 3, and 3 here goes here 1. So there is no remainder. So that tells us that 35 squared minus 1 all over k is an integer when we choose k equals 12. So let's go to 17 before we go to the last one. So let's go to 17. So when k equals 17, so that's for E, when k equals 17. So when k equals 17, so what we have is going to be 2 times 17 times 2 times 2 times 3 times 3 divided by 17. So obviously you would observe 17 crosses here, and then there is no remainder. So that tells us that k equals 17 also passes the test. So without mincing words, you should know that this odd man out here should be, the remaining number here should be the odd man out. But anyway, you might want to confirm to be double sure. So let's see. When k has the value of 16, let's see if this is still going to be an integer. So that's for the last case. So which is D, when k equals I've forgotten. Okay, that's 16. So when k equals 16, so I'm using this. So when k equals 16, so what we have is 35 squared minus 1 divided by k, which is 16 now, is going to be, so our 35 squared is this here. So that'll be 2 times 17 times 2 times 2 times 3 times 3 divided by 16. So 2 here gives you 8, 2 here gives you 4, and 2 here gives you 2. So but then when you look at this, 3 is not divisible by 2, 3 is not divisible by 2, 17 is not divisible by 2. So that tells us that the solution of this is just going to be 17 times 9 divided by 2. So there's going to be a remainder here. So that tells us that this is the only one that does not satisfy the condition. So our answer is D. That completes the problem. Thank you for watching.